CScIence.
The year is 1997. Police are called to a house fire in Perth, and once the flames are out, they find the body of a man inside. He'd been murdered before the fire was lit, but neighbours say that no one came or went from the house on the day of the fire. Police are at a dead end. But then they find a blood-soaked doona in a bin near the house. And on this doona they find some big, juicy maggots, and these maggots change the course of the investigation. In this episode of CScIence, we're going to take a look at how maggots and other insects can be used to solve crimes, and how they were used to solve this crime as we take a look at forensic entomology. And I have worn my dragonfly earrings, especially for the occasion. The world's first known forensic entomologist was Song Qi. He published a book in 1247 in China called The Washing Away of Wrongs, and it's basically the world's first known forensic science textbook. In it, he describes the murder of a villager who's been stabbed to death. Authorities identify the culprit by having all the peasant workers lay out their sickles. Flies are attracted to one sickle in particular, the sickle that has invisible amounts of blood on it, and the owner of this sickle was arrested for the crime. But in most forensic entomology cases, the insects are found not on the murder weapon, but on the body.
There are several methods to help us determine time of death, including maggots.
A few knife marks and some maggots. You know, this might be enough in the UK, but not here. Unless, of course, the maggots can stand up in court and give evidence.
Well, maggots actually do stand up in court and give evidence. Well, they don't exactly stand up in court, but that would be kind of cool. But maggots and other insects do provide evidence to investigations, particularly to work out how much time has passed since someone died. Insects are useful because they have life cycles with very distinct stages. A mummerfly comes along and lays her eggs. These eggs hatch into maggots, also known as larvae. The maggots feed and grow and eventually have to shed their skins in order to keep growing. They do this multiple times, and each stage of growth is called an instar. After reaching their final instar, they pupate. That is, they form a hard shell around themselves while they metamorphose, and eventually they emerge from the pupa as flies, ready to start the cycle again. Each one of these life stages takes a known amount of time, although there are some complications, which we'll talk about a bit later. So, for example, if a body is found with cute little instar 1 maggots on it, it can be estimated that the body has been there between 23 and 27 hours. But if pupa are found on the body, it must have been dead at least 130 hours, that is 5 days. So, back to the body in the burning house. The forensic entomologist could tell that the big juicy maggots found on the doona were 3 days old, which suggested that the murder must have taken place days before the fire. Police went back and re-interviewed the neighbours and found out that the murdered man had been heard arguing with his brother 3 days before the fire. It turns out that his brother had killed him during this argument and then returned to the house 3 days later to destroy the evidence by burning down the house. But it's not always that simple. The arrival and the growth of flies and maggots depends on a range of environmental factors, including the temperature, the season, whether it's been raining or not, and whether the body's been left in the shade or the sun, just to name a few. It also makes a difference if a body has been buried, covered, or just left out in the open. And if a body's been kept sealed away from insects altogether, maggots cannot grow, no matter how long a body's been there. And of course, different places have different species of insects, so it's really important to have local knowledge. Until as recently as 2016, all the information about what happened to human bodies that are left outside after death came from body farms in the US, but that has now changed.
It's all thanks to the work going on at a well-guarded research facility just outside Sydney. This is the Body Farm, or to be more accurate, the Australian Facility for Taphonomic Experimental Research. It's really rare, in fact, it's the only one outside of the US.
It's important to remember that it's not just one species of fly that will visit a body. Entire ecosystems pop up around bodies, and each species has its own arrival time and its own life cycle. Here are some of my favourites. The aptly named flesh fly, who is kind of cool because she lays live young instead of eggs. This little guy called the cheese fly because he'll only visit a body when it is decomposed enough to smell like cheese. And the carcass beetle, who prefers the body when it is more like beef jerky and only comes to feed once it is properly matured. And then we have the parasitic wasps that don't come to feed on the body at all, but to lay their eggs inside the pupa of the flies that are feeding on the body. And once all the flies have finished up and moved on, along come the moths who come to feed on the hair. So there's a lot going on. A body becomes its own little ecosystem and it's really cool. And if it wasn't already complicated enough, forensic entomology is also being influenced by climate change. The common greenbottle fly is used by forensic entomologists in the US state of Indiana, as well as many other places, to work out time since death. But as temperatures have risen, some fly species have migrated to cooler climates. The Australian sheep blowfly, which used to only be found further south, has migrated and is now also found in Indiana. So why does it matter? These flies look very similar even to entomologists, but they arrive at a body at very different times, which means mistaking one fly species for the other will cause forensic scientists to arrive at the wrong time of death. Thanks, global warming. So that's been just a little insight into the amazing world of forensic entomology, a world where the closer you look, the more you see. So I'll leave you now with just one last close-up look at this wonderful world, a photo of a beetle's head. So cool. But that is all from CScIence. But please remember to like us on Facebook, follow us on Instagram and Twitter, and check out our new webpage. We'll catch you around.